All right, welcome to day 2 of 2.2, finding the zeros and multiplicity of zeros. The first video was pretty easy. We figured out the end behavior. You didn't even need a graphing calculator to figure out the end behavior. What we're going to do now, we're going to take it another step. We're going to try to figure out all the middle part of the graph. I know on the ends how it acts, whether it goes up or whether it goes down. But really, to figure out the middle part, I always kind of call it the meat and the potatoes of the graph. We want to find the zeros, and then we're going to kind of see how the graph behaves at the zeros. Okay, so let's put this down. Let's put 3 key steps, and again, we're going to come up with a rough sketch for the graphs. We're not even going to need to use our graphing calculator. It's just a rough sketch of what the graph is just by looking at the equation and doing a little bit of work. All right, how to graph any polynomial function by hand. Number 1, we're going to do exactly what we did in the last video. We are going to find the end behavior. So we want to figure out, just by looking at it, what the degree is. Right? If the degree is even, they both go up or they both go down. If the degree is odd, it looks like an S-curve. One goes up, one goes down. Now, what's going to be new today is steps 2 and 3. Now, number 2, actually, this isn't new. You've found the zeros before. We're going to find the zeros for each graph. And remember, when you find the zeros, you set f of x equal to 0, which is really setting y equal to 0. So if you're setting y equal to 0, you're finding the x-intercepts. The x-intercepts of a graph, they're the zeros of that function. So you've really done this before. Actually, what's new is this. I'll star this. Now, just like we determined end behavior, now I'm going to determine the behavior at the zeros. So let's put that. Determine behavior at the zeros. All right. So this is kind of our template to get any rough sketch of a polynomial function. All right, let's do the first one. And we're going to follow this. We'll go back to this, steps 1, 2, and 3. Okay, again, I'm not using any graphing calculator here. I'm just going to follow these 3 steps. Okay, first one, I notice, okay, if I want to find out end behavior, the degree is 4. Okay, and it's a polynomial. It's not factored out. And the leading coefficient's negative. So this is my end behavior. They both go down. Okay, it looks like an upside down parabola. Now step 2, I want to find the zeros. So if I set this f of x equal to 0, the key for this is you want to factor. Let's see, if I factor this, I'm going to take out a negative 2. You can take out a positive 2, but I think it's easier to take out the negative. The other thing too I missed, we can take out x squared too. So we're going to take out negative 2x squared. That's our common factor. So then on the inside, we get x squared. Now, since we took out a negative, this plus here is going to turn to a negative. So that's just minus 1. And then if I factor that even further, we have negative 2x squared. And then this x squared minus 1, well, that's the difference of 2 squared. So it's x plus 1, x minus 1. All right, and then when we solve for this right here, well, we get x to equal 0. For this, we get x to equal negative 1. And then for this last one, we get x to equal positive 1. Now remember, these are the zeros. These are the x-intercepts. So I'm going to graph 0. Okay, these are going to be close together, so it's going to be kind of tough to show. Negative 1 and positive 1. All right. And then I'm going to put the end behavior. I know the furthest left 0 is at negative 1. I'm going to put an arrow here. Again, it's just a rough sketch. And then I'm going to put an arrow furthest to the right. Now, at this point, what I want you to do, I want you to stop the video and graph it. See what happens when you graph this. And now we're going to do the third step. We're going to observe the behavior when the graph hits the x-axis, when it hits the zeros. Okay, so stop the video. Now you can graph this on your graphing calculator, and we're going to come up with a conclusion. And then once we get this conclusion, then we really don't need the graphing calculator. But for now, you can use it. Okay, so hopefully you graphed it. Now when you graph this, what should happen is this graph, it should go up to negative 1, go up just a little bit, and then when it comes down to 0, it bounces off of it, and then it goes straight through x equals 1. So it almost kind of looks like an M. Right? Doesn't have to be pretty, doesn't have to be perfect. That's just the general behavior there. Okay? So I'll put right here the key part. Let me put this in a different color. At the origin, this is where the graph bounces off the x-axis. And we basically, what we want to figure out is, well, when does the graph bounce off the x-axis and when does it go straight through the x-axis? Okay, number 2 will kind of help us out. Number 2, now there's actually not a whole lot of work to do. The first thing you have to do to number 2, all right, so we'll start off with red. Let's figure out the degree. This is already factored out for us. So this is like saying x minus 2 to the first, 3 minus x to the first. If I add the 2, the 1, and the 1, my degree is 4. So they're either both going to go up or both go down. Since all these x's are positive, ooh, actually, you know what? This is negative right here. So this is going to give us positive x squared. This is still just positive x. This is times negative x. So when you multiply all these out, it gives you negative x to the 4th. All right, so as I was saying, the negative x to the 4th, this is going to be a parabola that goes down, or it's similar to a parabola. Okay, and then now what we're going to do is we're going to find the zeros. We already did the first step. Now this is the great thing about this one. When we find the zeros, unfortunately I can't erase all this work, but when you find the zeros here, it's already factored out. So for this x minus 1 quantity squared, I'm going to squeeze this in here. Again, I apologize for being messy. This is x equals 1. That's a 0. For the x minus 2, x equals 2 is a 0. And for this 3 minus x equals 3 is a 0. So not a whole lot of work to do for this. So let's graph the intercepts. We have it at 1, 2, and 3. So we got 1, 2, 3. Again, they're close together. And then let's put the end behavior in. I see the end behavior. They both go down. So to the left it goes down. To the right it goes down. Now, if you graph this, I'm just going to skip right here. If you graph this, what's going to happen is it's only going to bounce at the x equals 1. At x equals 2 and 3, it's going to go straight through. So let's see here. When I go up to x equals 1, it's going to bounce off of it. Okay, it's going to go straight through x equals 2 and then come down and go straight through x equals 3. So you see how it kind of matches up with the end behavior. So again, when I put this in a different color, let's put this in blue. Here's the only bounce. All right. That's the only bounce. And what you can kind of conclude right now, whenever you have the polynomial function factored out the whole way, when it's factored out, if this number is raised to an even exponent, like it is here, this is where you have a bounce. For number 1, this was raised to an even exponent. So that 0, this is where you have this bounce. If it's raised to an odd number, like this, 1 and 1, then it's going to go straight through. Okay, so let's go to the next page. All right, so if we're on the next page here, number 3, I'm going to do this real quick, and I'm not even going to use the graphing calculator at all because we've kind of summed it up. So if I did number 3 pretty quickly, let's see here. The end behavior now, this is just like number 2. It's factored out, so you'd have to add these exponents. So you get 2 plus 3, which is 5. So your degree is 5. So your end behavior is going to be similar to an S-curve. Since both these x's are positive, it's going to look like this. It's going to look like this S-curve. It's going to go down to the left, up to the right. Now, if I do step 2, if I find the zeros, this is real easy. For that x squared, if you set that equal to 0, you just get x equals 0. For this x minus 2, if you set that equal to 0, you get x to equal 2. Now, if I do step 3, I know what it is. I know where I get a bounce. Let's put this in a different color. Let's put this in red. Now, this 2 is the only one raised to an even exponent. So for this 0, that's where you get a bounce. For this x equals 2, since this is an odd exponent, it's going to go straight through the x-axis. So let's put all this together. Let's graph the x-intercepts. We have 0 and 2. So we have 0 and we have 2. Then let's put the end behavior in. Here's the end behavior. So it's going to go down to the left and it's going to go up to the right. So as I said, at 0, there's going to be a bounce. So I go straight up. Okay, it bounces off of it. Then it goes back up. And then there's no bounce at x equals 2 because that's raised to an odd exponent. And you can see how it matches up with the end behavior. if you ever do this and it doesn't match up with the end behavior, then what that tells you is you either did something wrong with getting the end behavior or you mixed up where it should bounce. So let's sum this up. The summary for the behavior at the zeros. So if we say if you factor everything out, this k is often called the multiplicity for each zero. You'll see it say this a lot in the textbook. So if x minus a is a factor of f of x, then if that k is even, if that's even, then what we can say is there's a bounce at the zero x equals a. All right, because if it's x minus a, then a is the zero. Right, it's like saying if x minus 3, if that was a factor, x equals 3 is the zero. So that's why I use this a. So I put numbers in here just to make it more concrete. Now the next one, if k is odd, then the graph is going to go straight through. So we'll say the graph passes through at x equals a. All right, so you find the zeros, and then you basically just have to figure out, is there a bounce at that zero, or does it go straight through? So the key here is factoring. Okay, let's just do one more. Let's do number 4, and then you guys are going to do number 5 on your own. So when you come into class tomorrow, make sure you have number 5 done. All right, now unfortunately for 4 and 5, unlike 3 and 2, it is not factored, so we have to factor it out. But it does make it easier to find the end behavior. So that's the highest degree 4, leading coefficient's positive, so it's going to be like a parabola. It goes up to the left, it goes up to the right. Then if I want to find the zeros, I set f of x equal to 0, right? Now the common factor here is x cubed. Key is factoring for finding the zeros. So I'm going to pull out an x cubed, and then on the inside you're going to get 3x minus 4. Now if you set each of these equal to 0, well that's going to give us x equals 0. This here, if you set that equal to 0, let's see what, you add 4 divided by 3, so you get 4/3. So we did step 2, we found the zeros. Now let's figure out the bounces. For this 0, x equals 0, it's raised to an odd exponent, so it's going to go straight through. This 4/3, this 3x minus 4 is raised to the first, so that's going to go straight through. There's going to be no bounces in this graph. Again, I don't need the graphing calculator. I'm just going to get a rough sketch. I'm going to tie everything together now, the end behavior and the zeros. So let's graph. This is 0. Now 4/3, that's the same as 1 1/3. So let's go to 1 1/3, which is right about here. Let's put in the end behavior. This is our end behavior. They both go up. And then there's going to be no bounces. So when I graph this, this goes straight through x equals 0. It's going to come back up, go straight through 4/3, and look how it matches up with the end behavior. And I know this is a little sloppy, a little ugly. I don't care. I don't care. It's just a rough sketch that we're coming up with. And to get that rough sketch, if you know the end behavior, you know the zeros, and you know how the graph behaves at the zeros, whether it bounces or whether it goes straight through, then you have the rough graph. Okay, so right now, put it all together, get number 5, and follow those 3 steps, and you're good to go.